Hello again, this is Tom from EveryStepPhysics.com, EveryStepCalculus.com. This is a physics problem regarding springs, so that's what you're going to go to in my menu. And some people have written me and said, hey, I put physics into the calculator here and nothing happens. Well, you have to buy my programs first, and then I email them to you, and then you are instructed how to put them in your titanium calculator. Then how to put physics in here with the open and closed parentheses, and to run the program. Okay. I advise you on problems like this in physics to put the variables off to the side of your paper. Put m equals 1.8 kilograms, put the theta sign equals 31 degrees, put d equals just like it says here, and then put h, so that you're all lined up. You don't have to go back and maybe make a mistake or something like that. Get them all indicated on the side of your paper, and then run my programs. Okay, so you press physics here. I'm already at springs, and of course we want to do angled springs. There's horizontal springs and there's vertical springs. This one has an angle to it. It's on a slope 31 degrees. And then we look for what variables are given. So I'm already at, to save time, mass, distance, theta, and height. That's what they give you here in this problem, okay? And we're asked to find the spring constant. So we choose that. And you have to press alpha before you enter anything in these entry lines. For the mass, we're going to press alpha 1.8 kilograms. I do all the conversions for you because everything needs to be converted to kilograms in physics. So if they give you newtons, I would show you the formula for that. So it's 1.8 kilograms. That's cool. That's good. I'm going to enter the height that they give you. Okay, that's going to be alpha 4.8. And it's meters, so number 2. That looks good. You can press the number of what's in front, or you can scroll to it and press enter. They're asking for the angle, alpha 3.1. Yep, that's correct. And now the compression, alpha 0.48 meters, number 4. And they all look good here, so we're going to continue. The height of the object from the point of compression to a moment of release. Okay. That's the initial. I gave you a lot of calculations in the programs as much as I can, because save space, of course, and then here they're asking for the spring constant, so you're going to have to go through all the other calculations to get the spring constant. And they're all important in here. Remember, this is all really trigonometry and algebra. That's what they're teaching in physics now. In other words, you're trying to pull out isolate some value that's in a formula and then find the value for that. And of course, everything is with remember the hypotenuse and the opposite side, and then the adjacent side of a right triangle. And that's what they're always trying. That's why you're using sine and cosine and stuff to figure out those different things. So H1 is the vertical, 0.24722 meters. And then the height of you have to subtract that from the height that was given to get the correct height here, 4.55 meters. We have a vertical velocity going straight up. That's 9.4512. And then we have the initial velocity, which is divided by the sine of theta. So we have the opposite side, when you divide it by sine of theta, you get the hypotenuse. So this is 18.351. That's what the initial velocity is up the slope, the slant of the slope, okay? And then we have the range where it hits if you shoot it off, where it lands up. It's 30.308 meters, and there's the formulas for that. It's right on your paper. We have work. Remember, potential energy is always equal to the kinetic energy. That's the conservation of energy in physics. And they have different formulas. The spring energy is 1/2 kx squared, the distance of the compression squared. Kinetic energy is 1/2 mass times the velocity squared. So we find k. Here's the formula for k. We're using the vertical velocity to find the spring constant, 697.86 Newton meters. So we've answered this problem, okay? There's other things in here too, work, potential energy of the mass, and then we use that to find the L. L is the actual spring relaxed condition of the spring, okay? The length of it. And then you go back and look at the answers again. Press number 1. You can go back and look at all the answers to check things. So pretty neat, huh? EveryStepPhysics.com. Go to my site, buy my programs, and pass physics. Simple as that. And don't forget calculus either, you know. And of course the calculator is worth more when you sell it. If you sell it, it's worth more when my program's in it than without. But I would never sell it because all your knowledge about physics and calculus is in that calculator. And certainly calculus, you know, business, you're going to business calculus and all that stuff. So the books are worthless, but the calculator with my programs in it is very valuable. Hey, have a good one. I'll help you all I can too. You can send me tests. I'll show you how to do it. You can call me. I'll, you know, help you with loading the program. Whatever you need help with, I'll help you. Okay. Have a good one.